is an honor and privilege to introduce Sri PVSS Jayaram Garu, Director AMD to you all. Sri PVSS Jayaram Garu is currently working as Director AMD Hyderabad with 26 years of experience in the field of VLSI. He is a gold medalist from Nagarjuna University. Prior to working with XLNX AMD, he had worked at CDOT and ETM working on telecom and wireless LAN IP solutions. At AMD, he is responsible for development of multiple IPs. He is holding 8 patents. Resource and power optimization for FPGA memories at system level, programmable clock monitor in a system on a chip, time-aware DNA, discovery and configuration mechanism for an integrated Ethernet bridge and end station solution, a scalable tweak calculation engine for AES, XTS cryptographic mode for block-oriented storage device, coordinated power management in smart SSDs, a distributed key generation architecture to enable line break encryption of small packets in AES GCN, FPGA SSD pairing for computational storage drive. Jayaram Garu had played a pivotal role in recruiting the students of NRVJIET. With these words of introduction, I request Sri PVSS Jayaram Garu to address the gathering. Yes. Thank you.
Hello. It's mute. Hello. Is it okay? Okay. Hey, thanks for the opportunity. This really, I would say this is really an opportunity because my site head is supposed to be here. He got a personal appointment and then he sent out a mail saying, hey, anybody else is interested? I just said, okay, I'm interested. I didn't know what's the theme about. I till yesterday and I was talking to Satish Garu and basically I was under the impression that it's for the students also, but and in that sense I've prepared the slides, but maybe also I can repurpose them and let's see how it is relevant at this point. So this question of like whether which one to select, right? And I'm seeing this whole intrigued, right, question about, hey, for the kids to select electronics versus computer science, right? It is not new. At least when I came in 1993 for counseling to Hyderabad, right? Sir. Hello. Okay. So I got into the counseling and then I chose electronics and communication. That time the computer science stream was new. It is back in 93, right? So, and then when I came back and said I chose electronics, my mom said, why did you do that? Computer science is latest. So it goes by basically the what you call the assumptions that what is the talk in the buzz in the whole society, right? I think electronics is suffering from that even now, if I hear that. But I think fundamentally it's more about, but I mean, fast forward 26 years, right? I don't regret my decision. In fact, life actually is only once for all of us, right? I mean, whether you did a right decision or not, you comparing with your colleagues, how they traveled along with you, right? So when I compare with all my friends who joined along with me in computer science and here electronics, I would say I'm better. Okay. So I think that should give. I think this is what we should see it as a. There's nothing right or wrong, or nobody is going to say what is right or wrong, right? Because this is what you have to judge from the people, how their career path has been, and you've seen all the distinguished people here who have succeeded in life choosing this path, right? So I think we should just come out of that and say that if we actually trust and in the path that we have chosen, we should be able to excel, and there are plenty of opportunities, and now it's actually growing with the especially the focus more happening on the semiconductors growth in India. So I just will start with how my career has been, and then I'll touch upon how the students should look at it from the career perspective. I started as in CDOT, Center for Development of Telematics. It's a telecom R&D company. I started with the PCB design. The reason I'm saying, basically it was like a circuit which we were supposed to design for interfacing the telephone line to the telephone exchange. So the thing starts from there. Like the one that lands on the telephone exchange is this line lands on a transformer, right? Which is supposed to separate out the AC and DC paths. Okay. And then you will have to also, because if you remember, the telephones don't actually get local power, right? The power has to be coming from the telephone exchange. That means somebody is feeding the DC line, right? It has to traverse so much of kilometers, and then you need to limit the current. And the current needs to be limited if the telephone is very close to the exchange, or if the telephone is very far to the exchange, right? You need to be sending a different currents. You need to be sensing current. You need to, when the telephone goes off hook, right? You get the dial tone. How do you think somebody is detecting that? These are all electronics, right? Somebody is detecting the current flowing and not flowing, and then deciding immediately to feed the dial tone, right? So then there is MTB, the DTMF, right? And there is a pulse. Everything is electronics, right? And from there, the digital thing takes over, right? The PCM, all your modulation techniques, all the other things will take over, right? So with the simple line interface circuit, I had to learn, I could learn a lot more, right, of what is studied. I mean, what is studied is probably, it's what I mean to say at this point is that it is the problem statement or the problem at hand that will make you learn more or relate what you learned to, right? So always, as a student or as a faculty who is guiding the students, look for the problems. Whether it is a solved problem also is fine, because most of the times you try to be like flashy and all. It need not be, right? Just take a solved problem and see how to how people understood that, whether it is solved or not, right? How it is solved. It will give you a lot of learning, right? So from there, like we evolved into like from transformer based to semiconductor based line interfacing. That itself had a challenge, and we went and solved some things like lightning problems on the telephone exchanges, right? Trust me, we went into gas discharge tubes level, right? It is going in the other direction. So things can be, all you need is a challenge and a problem, and somebody is asking you to solve it. Then you get the solution, right? Okay, so with that as a starting point, I want to disclaimer, this is all my personal views. I am not, right, this is not my company views. So what I want to say is that this is, you here is not faculty, sorry, so it is basically the students. When whatever you learn, that's what I was saying, like when it's all get utilized, put to test when you start into the job. So you need to, the students need to ask the questions like, do they really have what it takes, right? And and are they ready basically. Now, I'm from, it's not surprising that I will vouch for ECE because I would say it's niche area and also it's not crowded. Okay. I mean, it's a loaded word and maybe some people can get offended, but it's not crowded. Okay. Not anybody can get into it, right? But if you get into it, like you are really you can actually make a difference. So you, like other people have pointed out, it's very difficult. It's not a 9-to-5 job. So it's intellectually challenging, right? If you have a real problem at hand and you can't measure the time and say, I'll just do this and then come out, right? You have to solve the problem. And that's why you are valued most, right? I observed a trend. Basically, it used to be that the core architecture, core designs never used to come to India. It used to, I mean, you can relate, right? So it was like we just used to do the leftover jobs, like, okay, testing, validation, things used to come all defined and people are asked to just do the mundane job. But now it's not the same, right? Things like CDOT, these people actually have changed the whole narrative and they started building the ecosystem and the actual core designers who in turn actually inspired others to pick up those trends, right? So I've seen like both as part of Xilinx as now as part of AMD, I've seen like how the architectures are being, the whole silicon itself is being designed and completed, right, from India itself. So that didn't happen overnight. It actually took a lot of perseverance from all these people. In fact, some people out of passion came back from US and then settled in India and then actually helped others to build that confidence, that, right? I'm not denying the fact that they have advanced knowledge and all the accessibility and universities, but we are no less. Basically, we just needed opportunity, and that's what I want to say, right? The work that you do here is in semiconductor is challenging, and it has very high growth opportunities. And you've seen all this, right? These are the companies, and not necessarily everything is, I mean, I might have missed out some, but these are the representative companies actually as a semiconductor guys you should target, right? And I think our colleagues talked about these are the technologies, right? But then most of the times this is what you see the companies, you hear about the technologies, but how do you relate it to your curriculum, right? So all this basically, whatever the curriculum has in terms of digital electronics, VLSI, communications, and your microprocessors, memory interfacing, DSPs, everything now has a place in the technology that we develop, right? So it's just that the problem that you need to have a real problem in hand. That's all I'm saying. So before going there, I just want to say that most of the times when I hear about when I talk to students and then ask about the projects that they do, right? I don't see the project is being taken as seriously compared to when I hear about my friends' kids and all, when they do a project in US, they take it like literally, they want to solve it, right? They want to understand and solve it. But that's not the mood here. I don't understand why. Is it because we don't have the real problem at hand? We don't have enough people to guide. We don't have the faculty not having a good collaboration with industry. So I think that's something which is a single most problem to start with to solve, so that the rest of the things can be automatically can come in place. So it starts with projects. Whether you do a third year mini project or fourth year mega project, the emphasis on project should be very high and should be serious, and it should be result oriented. You can do a simple project of water level sensor on the water tank. It could be as simple as that, but it has to work. The damn thing has to work, right? and make it real. It cannot be like I go to some place and I buy project. It's like it's a trend. I mean, I know that it can be bought, right? Then you're not building an engineer basically, right? So I think as a faculty, if you can, one goal, if you can take that, make the projects real, you are really building a good electronics engineer. That's one single point I want to put across. But this is really, don't try to debug it as an FSM I put, but it's more of how a person who's doing a BTech or MTech has different paths, right? My main focus was to, like, if you want to join a tier 1 company that I have shown, or a place where the real semiconductor work happens, there are paths, right? Because most of the companies that I've shown, they generally go to only the IITs. But then what happens, that could be another reason why the people here get discouraged, right? Okay, I mean, why these companies don't come to me, how do I get into that? Because that's where the real work happens. So I've shown different possibilities. This is out of my experience of how people got into the companies, right? Finally, they're going into the targeted companies, right? So the one that I've drawn pictures, like if the out of graduation you want to go get into tier 1, the company, the institute reputation has to be very high, and that's why basically the companies try to go there. It's a overall chicken and egg problem, right? So if the students are, if I come to a right in institute and I found the students are very talented, and then I basically come again, and then that's how it goes, right? But if I come and say, okay, they're not able to answer basic questions, then it will not build that whole thing. And the strong academics, right? Both go hand in hand and that needs to be built over time, and that needs to be maintained as well. And for the students, basically, we need to focus on the domain subjects and more understand them in a practical way. That's what I would say. It is again like for people who want to see the growth in the organization, or like, for example, somebody wants to have a clarity on how do I become a CEO of a company, right? Again, this is not a known formula. I'm just saying this is out of my visualization. At some point in career, people will want, hey, I want to become a manager, or I want to stay individual, right? This is a question we keep getting asked. But no matter what, your technical skills have a weightage, but at the same time, don't undermine the soft skills, especially being able to articulate your thought process, what's going on in your mind. If you're not able to put it across, no matter where you stand, whether it's a core company or normal company, you will not be able to excel. So I think as a faculty, you should encourage the other side of the soft skills part of the whole thing, because the guy should be able to confidently stand up and tell whatever he's learned, right? Most of the times in interviews, that's what we look at. We look for also, right? So that this is very, very important. Soft skills, please don't ignore. Again, the point here is for the faculty to what to focus on. That's all I have. Thank you.